Finally, one might be interested in some downsampling. Given that we have already interpolated the signals from all the neighboring pixels for any pixel, we might want to preserve only significant information. So it is possible that there is some contiguous object. Here's an example of a vehicle such as truck. The body of the truck might have some homogeneous color here. The background might all be white, or it might just be tar road. So in such a setting, given that we have already found patches and interpolated, we probably don't want to compute information across all patches, and we might want these patches to make strides so as to avoid preserving or even computing redundant information. So as you can see, these patches move at some regular intervals, which are called strides, and all the other computations are thoroughly avoided. This might amount to dropping computations at h5, h3, h1, and so on. In fact, one of the important parameters in convolutional neural networks is the stride length. The stride length that we have discussed so far is 1, but it could also be 2, and so on. When you adopt a stride length of say 2, it's possible that some of the patches, as they move onto the corner, tend to overflow, as you can see here. Now one can use a host of possible padding techniques which either ignore those sections of the patches that overflow by using padding values of 0, or one could have structural constraints with a fewer number of perceptrons in subsequent layers in order to explicitly ignore or avoid computing these values. So the basic idea of striding is considering only HIs where I is a multiple of S. So these strides typically result in these patches moved with some periodicity. So stride of S would correspond to moving the patch by S steps at a time. There is a more interesting aspect to this moving of the patches, and that is downsampling. What you are doing in the process of moving the patches through strides is actually downsampling, where you are implicitly accounting for all the signals but might explicitly ignore some of the computations. What do you do at the ends or corners? We suggested padding either with zeros, and that has a name called same padding, or let the next layers have fewer nodes, and that has a name valid padding. In general, strides, which amount to downsampling, reduce the storage requirement, and interestingly they also reduce the prediction time. The storage requirement goes down primarily because one has fewer outputs to store in the intermediate computations, and prediction time gets reduced because you even avoid making some